Just a quick video that may be of interest to some of you. This one is all about hidden surprises that you find when experimenting in the lab, which, let's face it, that's why we do it. I was setting up a lab to record my next video, which will be all about an LDR potential divider circuit. The design is on screen now. Using a 1 Hz sine input into the divider, I quickly adjusted my scope to show 2 channels, yellow on the input and blue on the output. Then I turned on my LED torch, placed it over the LDR, and this trace appeared, which I thought was good. It was an incredibly powerful torch, mind, and the lab was in darkness, so I could get a good contrast. And it just was far too bright, it was blinding me, so I thought, right, let's just switch the LED torch into dim mode, which I did. Then I looked back at the scope, and I saw this, and noticed the blue traces has weird sort of thick line in the peaks. And this is why I love oscilloscopes. If I wasn't scoping this, then I would never have noticed it at the time. So, something has changed between using the bright setting and the dim setting on my torch. The sine input hasn't changed, the circuit hasn't changed, so we know it has got to do something to do with the light source. Zoom into the thick blue waveform, it exposes the reason for this and why it looks so thick. Can you see it looks like some sort of strange sawtooth? Let's now change our input from a sine to a DC 5 volt and see if that clears things up. And look at that. Now we get a lovely waveform to study. I've also enabled the frequency counter, and you can see we have about 203 Hz. This is where I leave it to you, I'm afraid. I don't want to spoil your fun of working this out. Leave comments below of your answers. All I can say is that it's obvious when you think about it. The torch is the key. If you want to see this next video on the LDR, it'll be up next week. Keep an eye out for it. Until next time, keep experimenting.